off. There will be a short question and answer session at the end of this presentation, which should take no longer than an hour. Then a small introduction from my side. My name is André Veldsman. I'm a product and business development manager at Tandem Technologies. We are a specialized test and measurement engineering firm. We specialize in high-end sensing and data acquisition technologies. One of those technologies is Ouster LiDAR systems, which we represent in South Africa. And a short while ago, we approached them to be able to give more turnkey integrated solutions into the South African market. They put us in contact with com-iot technologies. And the moment I saw what they were able to do in the security industry, I decided to put all my time and effort on that. And by the end of this presentation, you will all realize why that is. So from my side, I'm going to give the floor over to Mohammed. He's going to do an introduction and then follow with the presentation on that. Mohammed.
Thank you very much, Andre, and thanks everyone for joining this presentation. My name is Mohammed Sadiq, and I am the founder of com-iot Technologies. Com-iot Technologies is registered in the UAE, in particular in Dubai, and I am going to share screen with your permission. Com-iot is one of the oldest AI companies in the region. This is our 7th year. We work in security and we work in mobility. Let me know if you can see my screen.
We can see it.
Okay, great. Yes. So these are our operations around the world. We are also registered in the state of Illinois in the United States. We have projects in Saudi Arabia with Saudi Aramco. We have projects in Qatar with the Ministry of Road and Transport. We have projects in Germany with the federal government and the municipality of the city of Russelsheim. We have projects in India with the Indian military, in Egypt, but most of our projects are in the UAE, in particular in Dubai and Abu Dhabi. The 3 balloons that you see here in the United States are for 3 granted patents by the United States Patents and Trademarks Office of the US government. These are the links to our patents. And these patents introduce perception systems that we have developed in our labs for vehicles and for people. And we will see how we are using these perception systems on LiDAR point clouds. We'll see what a point cloud is, what a LiDAR is, and how we use them. One of these patents is for autonomous vehicle perception system software. Most of the autonomous vehicle companies use parts of our method, our invented method. This is a picture of a company that is in San Francisco and has the LiDAR sensor on top of it. Our systems have been tested, examined, and accredited for accuracy by MITAS of the Swiss government in Switzerland, extensively over a period of several months. And they described them as perfect. And they issued a final report with the results. Our mobility and security solutions have been reviewed and evaluated by Startups Inside of Austria in Europe. In May of last year, they reviewed 244 mobility companies using artificial intelligence in their solutions. And if I click on this link, we'll see the report that they have produced on their website. The top 5 out of 244 was com-iot Technologies, then a company from the United States, a company from Italy, China, and the Netherlands. In July of last year, 2022, they reviewed and evaluated 487 companies working in security, in city security solutions. And clicking on this link shows the top 5 report. And number 1, again, was com-iot Technologies, and a company from Finland, France, the United States, and Canada. So we have been reviewed, we have been accredited, we have been evaluated, and we have been granted patents for our inventions. This is an image from our project in Germany. So we do a lot of mobility solutions. Today, however, is dedicated to security solutions. In particular, I-Trac. I-Trac is the name that we have given to the security platform. That platform carries multiple solutions that use cameras and LiDARs, or both cameras and LiDARs together. We do crowd management through counting of people. We have a solution called iCount, facial recognition with iFace, intrusion detection and perimeter protection. Those are the two best sellers within our portfolio. And then we have access control and border monitoring, entrance and exits. We have the US patents granted for security with PRT. We will go through people recognition and tracking. And then we have violence and aggressive behavior detection. And we have automated weapon detection systems. We're going to go through all of these, and I'll show you some interesting tests and test results and videos. I want to start by showing you this video, just to stimulate the discussion. What we're looking at here are two people about to enter a restricted zone, the red zone. Once they enter the zone, the camera rotates and moves to their specific location with coordinates, live broadcast video of their presence, and stores a 30-second video of the intrusion incident. And all that appears on a dashboard that is intelligent, that reflects and displays live continuous update of the intrusion incidents and associated metadata. The question here is, what is this? What are these blue lines? And how did these two people got to be looking like that, with bound in boxes and some writing on them? And how was this zone created? And how is that system all works, and what's VARSI? So in order to answer this, I would like to introduce you to a device, LiDAR sensors. Some of you may be familiar with it, some may not, but we're all familiar with cameras. These are pictures of different cameras from Axis and Hikvision and other, Bosch and elsewhere. On the left side here, we see images of LiDAR sensors. These LiDAR sensors, Velodyne, Quanergy, and Outstar, are just examples of LiDARs that are manufactured by United States-based manufacturers. LiDARs are now manufactured in China, in Korea, in Germany, and Canada, and in multiple other countries. We have introduced the first LiDAR sensor to the Middle East in our first week of operation 7 years ago. A LiDAR sensor emits light points or laser points or photons from inside of it, all around it. They go out, they fall on the first object they meet, and then they return to the receiver inside the device. And they do that continuously, and they do that frequently and fast. And that continuous operation generates a 3-dimension map of the environment around the sensor. Here is an image of that. Here's a 2-dimension image of that 3-dimension map of the sensor. The sensor would be in the middle of the circle here, maybe on a pole, 3-4 meters. And you can see here structures and poles and light posts and people walking and vehicles parked and so forth. As opposed to a camera who does not go 360, they go with a limited field of view, whether you zoom in and out to adjust for your objective. A camera also gives us a 2-dimension frame, whereas a LiDAR gives us a 3-dimension frame. Here is a LiDAR frame. This is a single frame made by LiDAR. You can see here how a computer machine learning algorithm could have immense capabilities with the additional dimension. So you could span through that frame in so many different ways, from above, like a bird eye, and from the sides. Because it's laser, it allows for precision measurements of distances. So through this frame, you can measure the precise distance between any object and any other object within this. This is a cloud of points. These are the light points that are generated, and it's called point cloud. So the LiDAR generates a point cloud while the camera generates a video stream. So this is a camera video stream or one single frame. With a camera frame, you can only zoom in and out, losing pixels. You could also rotate the image. But for a machine learning algorithm, there is not much you can do beyond that. And LiDAR allows for that third dimension that gives you that much more precision. Outdoor performance with cameras also is subject to weather impacting elements such as rain and snow and fog and sand. These all deteriorate the video stream quality, resulting in errors and failures by the machine learning algorithms, object detection, and systems of this nature, whereas LiDAR is not impacted by all of this. Also, cameras require light. For operation, LiDAR is not a camera. It has no lens and is not impacted. It works in full darkness. In addition, sometimes we tend to use thermal cameras for human detection through body temperature. However, in hot conditions, such as where I am now in Dubai, where the temperature is 45 degrees Celsius, the body temperature is cooler than the surrounding temperature, and that results in failure by thermal cameras. Also, in very cold conditions, like in Canada, for example, in the winter, or Chicago, a thermal camera would also fail because of the layers of very cold clothing that on top of the human body, preventing a thermal camera from reaching the body temperature. Obstruction. Here we have one of our projects. We have a LiDAR sensor on top of a pole, and we have two powerful Axis Q1700 cameras. These cameras and this LiDAR are working together, synchronized and calibrated as in a device fusion state, frame by frame. So the above camera here produces this frame, the lower camera produces this frame, and the LiDAR has given us this frame. So all these frames are synchronized. And as you can see here, if this truck comes and stands here due to car trouble or accident, both cameras are completely useless. The field of view is totally blocked. Whereas with the LiDAR, because of the third dimension, you are able to see the truck and everything around it and in front of it and behind it. So all of these are valuable features of a LiDAR sensor that provides companies like ourselves immense capability in achieving our objectives, whether in mobility or in security. This is a list of the different variations between cameras and LiDAR sensors. And we use cameras a lot in many of our solutions, and you will see that. Now, here's an example of our people perception. So we developed a perception system that takes the raw data, which is this blue background here, generated by the LiDAR, known as the point cloud, and looks for people within this raw data, and only people. So the algorithm must not be confused with light posts or trees or dogs or horses or any non-human object, including fog and rain and other weather elements that may appear in the shape of a human. So the algorithm, the higher the accuracy of the algorithm, the higher the accuracy of your system. So here we are seeing people. Everyone is detected, is tracked, is assigned a unique ID. They are all in motion. And we are then able to apply different applications. We can deploy zones or virtual lines to count people crossing as entrance or exits monitoring. So you see here real-time calculation of the people crossing. We can create a rectangle like this one that will always tell us how many people inside of it. So you can get exact, precise count of the people inside this. You see the numbers here on the left side being reflected. Look, now it's 0. Then it becomes 1, 2, and 3. Then it becomes 2, 1, and 0 again. So extreme precision of the of people perception. Now, we have also taken Varsity on the road. So instead of having it stationary on a pole, we put it on a moving car like this one. And then we are able to detect people while the car is in motion, while the people are also in motion. This video here, taken from one of the streets in Dubai, shows people being detected and tracked. Everyone is, again, assigned a unique ID. And think of the immense capabilities that you can do with a mobile people perception system. In military applications, for example, on combat vehicles or on tanks, where you need to detect people or search and rescue, for example, in the jungle, in the desert, in mountainous areas, where you want to find people and you want to find them fast from a moving vehicle. So this is a people perception on LiDAR point cloud. Here, the point cloud appears in the color, in the red color. So that is just a high-level introduction of the people perception system and how it's used. Now, I want to show you a little bit more into people perception. On the left side, we have raw data generated by a LiDAR sensor from a convention, a conference, from the exhibition hall. These are people in motion. There is a lot of crowd going in all different directions. And on the right, this is the people perception, Varsity, detecting and tracking every one of those people and their movement. We are able to not only detect them and track them, we're getting their velocity, their trajectory, their coordinates, their specific locations, all in a live continuous update that we can then use in a variety of different applications. So here is a really good example of people perception. Now, I have listed the security solutions that we have. Let's go a little bit deeper into that. These are the list of solutions. Here's an example of the smart pole. The smart pole, because we use camera, it has a LiDAR sensor up on top. It can have different heights, and it has a fixed camera, which we use for facial recognition, as a PTZ rotating camera, which we use for a lot of our security solutions. And the solution, the video that we have seen together earlier, where two people are going into a restricted zone, basically is done through the Varsity system, whereby, here it is again, the I-Trac has a graphic user interface that allows us to display zones and precise locations as per the requirement. And those people are detected by the people perception. And as they hit the intrusion area, they are immediately captured and taken as we see. Now, other examples of that. Now, before I do that, I want to show you how the camera is moved. This is the PTZ camera. This camera is made by Hikvision. It moves left and right, and it also moves up and down. The movement that you are looking at is completely controlled by the LiDAR sensor, or rather by the algorithm itself. It is moving it through the UNVIF protocol to very specific location for very specific purposes, whether to broadcast or capture an image or a video or whatever the camera we will do. So that's how we move this camera. Now, let's look at this example here. There's another example, very similar to the previous one. We see a person outside the restricted zone. These are all different zones attached together. You can see a very flexible way of building your restricted zones. When he hits the red zone, the alarm is fired and the camera is open and moves to that specific location. In this example here, we have multiple LiDARs, multiple PTZ cameras, and multiple zones. So I want to show you just a picture, maybe I think it's toward the end where we show the full. Okay, let's go through it together. So here, there's a one person going. This is unique because you see, you have a LiDAR here in the middle of the circle on a pole, and this person is going into the red zone, and the alarm will be fired, and a video will be captured. Now, this particular person is doing a unique test. He's going through the entire area. And as he goes from one zone to another, the camera closes and opens instantly and continues with him. So he continues to be tracked by the same camera until he reaches the second LiDAR covered area and the second camera. And you notice that no matter how many LiDARs and how many cameras your project requires, let's say miles and miles or a big air base, then the design team will do as many LiDARs and cameras as required, and they all will work together as if you have one big device, one big LiDAR that also includes a PTZ camera inside of it, covering the entire area. And no matter how far this person goes in these zones, they will continuously be tracked and recorded and broadcast live as they move. We are looking at this person from his back. This is alert number 6 up here. As he goes to alert number 7, the same camera is capturing him. But when he finishes this zone and goes to the next zone, that's another camera covering this area. Watch. Here he goes, and the other camera opens, and now we're looking at him from the front. So you can never lose your intruder. And this system is designed so that it can capture multiple intruders intruding at the same time from different locations and different angles. So the system design covers for all this. It also allows you to have different zones, levels of security threat. You can say, for example, this is a weapons depot for the military. This area is high security threat. I need maximum protection. This area is medium security threat, and this area is low security threat. So you can develop the different zones accordingly, and the triggers by the intrusion incident can do different things. So in one area, you can send patrol or close the gate or wake people up or send text message, whatever the triggered events, sound an alarm, etc., etc. So you can have complete flexibility with the intrusion detection and perimeter protection system. Some other example of that are like this one here. This is the perimeter of a critical infrastructure. And you see the LiDAR view here with the virtual zone. Here it's in the yellow color. There is an officer testing and running to the wall, jumping the wall, and the alarm is fired, and the camera moves and records a video just like before. Look here, for example, The PTZ camera is looking far away from the wall. You can see the wall in the LiDAR view, but the camera is looking at the mall outside the building. But the intruder is right here. You can see the intruder down here. Once he intrudes, the camera moves and captures a live broadcast and records a stream of the intrusion incident. This is perimeter protection at its absolute best. Now, in security, we are used to different systems. I want to share with you what the kind of systems that we're used to having: automated systems, intelligent systems. We have the computer vision by cameras, visual analytics with AR, object detection. We have microwave radars, infrared systems, underground pressure sensors, motion detectors, thermal cameras, and audio wires. All of these systems are automated. There is no human intervention required. And every single one of them produces false alarms. They're just not intelligent enough. I have already covered why cameras can generate errors and failures. In fact, all of them generate false alarms almost continuously, because motion detectors has no distinction between objects and other objects. The same thing for underground sensors, the microwave radars, anything, a bird or a cat jumping through it will generate the alarm, audio wires, etc. So LiDAR, and we have this report from ADT in 2021. It says that 94 to 98% of all alarms are actually false alarms, and they're very costly, and they cause a lot of panic in the society and in the community. We asked ChatGPT, who can guarantee zero false alarms in perimeter protection solution? They said zero false alarms cannot be guaranteed by any technology or system. We asked Google Bar, who can guarantee zero false alarms in perimeter protection? They said no perimeter protection solution can guarantee zero false alarms. So and if you go on Google, the regular Google, and you type false alarms and perimeter protection and intrusion detection solution, they will give you the same answer, and they will give you a lot of companies, big name in security, that will tell you, we reduce false alarms, we minimize false alarms, we decrease and lower false alarms, but nobody will tell you, we guarantee zero false alarms. But we at com-iot give you that written guarantee because we do it. Because of basically, not only because we use LiDAR sensor and they are laser and high precision, but more importantly, it's the algorithm, the people perception that makes no mistakes. It is done in such a way with a certain amount of leverage and parameters that allow us to accommodate almost every condition on the planet. This is from our project in India, and here I'm asking him, the project manager, how do you find the test results? And the answer is no false positive. And if you look here at one of our projects with Siemens, they come out when the project finished, they said the successful project completion certificate, and this is actually January this year. Look what they said here. Since the system was commissioned, no false alarms have been reported, signed and stamped by Siemens, a Fortune 50 company headquarters in Germany. So we pride ourselves on the accuracy of our algorithm. We know, and we have worked in projects where half the project was given to us and the other half was given to a competing company that also uses LiDARs. But because we use cameras, we were assigned to capture all the alerts. So the alerts our system generates and the alerts their system generates. I'm not going to mention the project or the company. They also use LiDAR like us, or the country where the project is. But I'll show you the alerts that they have generated. They have so many false alarms, on the average 17 per day, after a year and a half of trying to fine-tune the system and reduce false alarms. Our half of the project to this day, over 2 years, provides zero false alarms. They have false alarms coming from birds, because this is an open area in the desert. or cats or other objects. If you see here in this report, some videos, alert videos, show nothing. It's possibly fog or some other weather elements and so forth. Single birds can cause alarms, many birds can cause alarms, etc., etc. So if you want zero false alarm for your high-end critical infrastructure, military site or government site or oil and gas, power station, airport, whatever, your best bet is always resting with Varsity. Varsity is such a flexible system. It allows us to build these virtual zones. Here is the point cloud. We put together these red zones for alarms. So these are intrusion zones. Any person going in there, the alarm will be fired. If there is a camera, it will open up. The blue zone down here is for counting people with high accurate directional precision counting of crowds. And this virtual wall in green here acts like an entrance or an exit or a border. Think of it as hundreds of miles of international border. And this will keep exact, precise count and monitoring of people crossing in either direction. You see it here saying entered and exited, 48 and 45. These numbers will change as people cross. Now, 45 became 46. And now 47, you see people are crossing. The alarms keep coming. This video here, if you look at it carefully, with every zone independently, with keeping an eye on the exact count for the alert zone, for the counting zone, or for the counting line, you will see that the numbers have extreme precision of 99.9%. And the only reason I don't say 100% is just because people don't like that. So I say 99.9%. Extreme precision of monitoring of people, no matter how many. So if you're in a prison and you're counting prisoners through mustering, which is done 5 times a day, this system for 5,423 prisoners will give you 5,423 without missing a person. So now I want to show you facial recognition. That's a camera solution. iFace is one of the highest accuracy facial recognition systems that I personally have seen. We used to use NewFace from before we developed iFace. So here, facial recognition is something we're all familiar with. You have a database, you have faces, image matching, and then you say, this is Bob, this is Mike, this is Steve. Here we have the system with re-identification, which means it doesn't have a database, it is building the database. Think of it as a camera on the street, where everybody approaching the camera is new, is not in the database, or in a hotel, or a hospital, or a customer care center, or whatever situation. So here we have this test with 4 people, Omar, Asaf, Muhammad, and Rami. The system looks at Omar for the first time in the first frame and assign him a unique ID. The ID is 0. Now, every time the camera sees Omar, it will retrieve the ID that it has been created in the database that it has just created. It only has Omar so far. Let's keep going. Then Asaf appears, and Asaf gets the ID number 1 right here on the left side. And every time Asaf appears, ID number 1 will be retrieved several times per second. And because the image matching is done several times per second. Then we have Muhammad. He gets ID 3, and then you have Rami, and he gets ID 4. And now these people will continue to pass in front of the camera several times. Any frame that you stop, you see Omar with the correct ID. At any given point in this long video, there has not been a single error. Here's Rami ID 4 and Asaf ID 1. Watch. ID 1 for Asaf, an ID for Rami. Now, these people are going to try to hide their face. If they are not wearing glasses, they're going to put glasses on. If they are wearing glasses, they're going to take them off, trying to change their faces. They're going to put a headset on or a helmet or a face mask. Let's watch. Here's Muhammad with glasses on. Remember, his ID was created without glasses. Also, Asaf took his glasses off. He's still number one. Rami 4. Muhammad with glasses is still number 3. I'll show you the face mask because of COVID and the headset. Here's Omar number 0 with the headset and glasses. Here's Rami with the jacket on his head, still number 4. Omar number 0 with the hard hat. Then Rami comes with a face mask. Watch. And this actually was done before COVID, by the way. I just want to mention that. Rami is number 4 with the face mask at 95.02% confidence level. So the confidence level registered frame by frame. Eye face, you have not seen anything like it. Now, what we added on top of this is field analysis. Field analysis is age and gender and mood. It's the same video, but now we're analyzing the facial features, characteristics in terms of age and gender and mood. The gender will be always accurate. The mood will be an aggregate of different moods assessment, and the age will be give or take, I believe, 7 years. So here, Omar is a male. He's about 28. In reality, Omar is 24. And in this frame, he looks neutral. The system gives from neutral and happy and sad and surprised and angry 5 different moods. It calculates every mood, and the dominant one is assigned to this frame. So you'll always have the dominant one aggregated overall for the presence, the duration of the person passing in front of the camera. And this is good for assessment of your customers at a retail store or at your school, the students, the people in the street. You're building your infrastructure wherever people go. You can get a feeling also of the age, the genders, and the population that are visiting the location. So field analysis is a new feature added to iFace. Now, I have shown you how we track people by people perception. I have also shown you facial recognition. What if we combine both of them together? Remember, Varsity allocates and assigns unique numerical IDs to people. But if we know the person's name through facial recognition, we can replace that ID with the person's identity. So, and that is PRT. PRT is people recognition and tracking. And in this video here, I'll show you how PRT works. I think, showed you the this pole here, the LiDAR and the facial recognition camera. Now, we have them as part of this test in an exhibition. Crowded exhibition, a lot of people moving around in all directions. I-Trac is tracking everybody, detecting everybody, giving everybody a numerical ID. Look, for example, at this guy here. His ID is 27039, 27056, and so forth. Now we have David. David is on a watch list, on a database. Let's say it's a blacklist for security, or he's a worker in a factory or a workshop or a student or whatever belonging to any database. We have his picture and we have his name. And he's going to pass in front of this smart pole. David will be tracked like any one of those people, will be given a number, but because the camera will recognize he is David, look here. Here in this picture, the image matching happened as David passed in front of the pole. Let's just 1 second. Right here. And here you see some interesting feature of iFace. This is the database image of David with his name on it. And this is the captured image during the exhibition. Look here, only half of David's face is showing at a distance of about 10 meters in the middle of other people and a crowd. And the system was confidently able to detect that this is David and generated this image matching report. And once David was identified by name, his box here, the bounding box surrounding him, will no longer have the numerical ID, but it will have David's name. And David's movement path will be tracked and displayed live here on this tracking screen that has a layout map of the location, in this case, the exhibition booth. So if I play this video, you see here, David is moving. You can see him in the camera view, also in the LiDAR view, and he's moving, his movement path is displayed here in real time. This screen can be on a handheld tablet in the hand of security personnel at the airport terminal, as well as on the screen in the security office, on the command and control. And look here, as I mentioned, David is defined by his name. Can you all see David here? Name David. He's the only one that doesn't have a number ID. So David is being tracked by his own identity. And this is the heart of the invention. It fuses facial recognition into people perception of LiDAR into each other, resulting in real-time exchange of data between the two systems. So now you can exchange the numerical ID by the actual identity, and you can display and record and store the movement of this wanted person live on a layout map on the screen. And now the people no longer need to go search for David. They know exactly where he's at. He is passing by the restaurant. He is moving to the duty-free. He is going downstairs. He's going upstairs. You know exactly where he's at. You can go and get him or speak with him. And here on the lower left corner, you have a heat map of the movement of the people. Heat maps are important because they show you with degrees of different color how much crowd is moving and where. So that is also a very important feature of I-Trac. So this is PRT. In short, if you want to put this at, for example, like I said, an airport terminal, here's an example of that. In this example, we have the airport entrance, the terminal's entrance, and we have a LiDAR sensor here and a fixed camera here, and they are both calibrated and configured and synchronized to work together as one device. The LiDAR is always the commanding device. People are coming in, they are detected, they're tracked, they're given numerical ID, they are counted, and they are checked against facial recognition database. In this case, John Smith has been matched and his alarm is alerted on his presence. And now John Smith is tracked by LiDAR wherever he goes in the airport terminal. You have more LiDARs and more cameras as required to cover the entire required area. And now this movement of John Smith is going to be instantly in real time live displayed on a tracking screen in the command and control with his picture, with his identity, on a layout map of the airport terminal. And you know exactly where he is. It could also be on the handheld tablet of the security personnel or whoever. And now a security officer does not need to do as they do today. They go out to camera 14 and which captured him, and they start looking for him everywhere. And they send people to the right, send people to the left. You go there, I go here. You don't need to do that. You know, you see, you're looking at his movement live. He is the officer holding an iPad and going straight to departure gate 24, where he knows John Smith is at. So this is PRT, a granted patent invention. And the system also applies outdoor.
How are you?
Yes.
I'm all right. Okay.
Is there a question, or do you want to have the question afterwards?
And I think continue. I think he was just not on mute by accident.
Oh, okay. So we have three people here coming out of a mall. We have a layout map of the location, and all of them are in the database. The image matching is happening here. The alarms are fired here. Their movement path are displayed live here on this layout map. Now they go anywhere. They don't even know what's going on, but their every step is being documented and recorded with their identity, their pictures, their names, the timestamp, wherever they go. And if one of them leaves and comes back later, or the next day, or the next year, and the system will record a new tracking movement for that person, and then will add this movement to the previous recorded tracking record in the same file. So you maintain a single file per person. And this is showing you multiple people in outdoor with PRT. Same thing happens here for multiple people in indoor. We have three people. We have David and Ken and Ahmed in an exhibition, in a conference. They are walking, their image matching, their movement is displayed instantly with different color codes for everyone. And you have that record as required. It's an amazing system, amazing invention that we have developed that shows you know, how you can apply security with advanced technology. In terms of perimeter protection, you want to apply perimeter protection on your prisons, on your airports, on your critical infrastructure, power stations, oil and gas, and so forth. In the United States, over a period of 7 months, there were attacks in different states on power stations. They have not been able to identify intruders. Power stations are always outside the city, far and difficult to reach. And with the amount of false alarms from automated systems, people just give up. So they are subject to attacks frequently, unfortunately. These are images from deployment of our system in different projects. You put poles or brackets. Here's the PTZ and the LiDAR sensors on these systems. Now, I want to show you this image. We're working, as I have mentioned, with Siemens, and here's a document that we're sharing because of our successful tests with various customers. This customer here released the tender and required all bidders to bring I-Trac from com-iot and listed our email so that nothing other than I-Trac technology is introduced for this particular security project. Here's another example from Asia. And here, what is unique is that this particular military location is bordering a forest with tens of thousands of trees. For companies like us, trees are a problem, not for us, but for the other companies that we're familiar with, because they fool the system and with the continuous movement of the tree branches and the leaves in the wind, they appear momentarily as humans and they can generate false alarms. But look here, you are looking at people walking on the walk tracks and not a single human detected inside the forest. So the Varsi is not fooled by all those shaking and moving trees and tree branches. There is another project in difficult weather conditions. This one also generates a sound with the alarm. Now I want to show you violence detection, aggressive behavior. You need this solution. That's a camera solution. You need this solution. This is a clinic where a patient is attacking his doctor. This is a real video from the TV. And look here, where the red aggressive behavior alert is displayed as long as the two are in violent contact. When they separate, the alert goes away. Watch. It goes away, it becomes green, it says no aggressive behavior. This is important because what happens today is that these things happen without anyone watching. And then when the doctor reports and complains, and if there has been a camera, they go back and check the recording. But this system allows you to intervene instantly and stop the attack. You want this in your prisons, you want it in your airports, in your concert locations, stadiums, wherever people gather, even on the street. Look at another example. This is also a news item about violence in hospitals. And you can see on the upper left side, the alert, now it's green. But when the attack happens, it turns red and it says aggressive behavior. Then it goes green again. So it's extremely responsive system and allows for human intervention during bullying in schools, for example, or any other aggressive behavior. Now, watch this one. These people are in contact, physical contact, but there is no aggressive behavior. It's a group hug, and the system is not going to react. It's in motion, it's a video, but it's not showing any aggressive behavior. Here's an incident that happened in March in Florida at a high school. It's a very unfortunate video. It's a student who's attacking his teacher, really violently. So I apologize for this, but to demonstrate the system, on the right side here is the system, here is the attack. It shows the alert instantly. This is the raw video from TV, and this is the system with our solution on top of it. Watch it again. Immediately, the alert shows as long as there is violent physical contact. Now, we also have a solution called Automated Weapon Detection System, ODES. This is a real event, unfortunately, from Tennessee, from Nashville, in the state of Nashville, in a school on March 28th. This is a mass shooter. This is from the news, from CNN. In fact, I recorded this on my own mobile. This is the raw video. Look at the raw video. She comes in, she's holding a gun, she's opening the office door, she's going out. Then she's gonna return back to the office with the gun in hand, shown to the camera. And she's coming in. That's the raw video. Now let's apply odds on it and look for the red alert. Here she is. She's detected as a person. The camera shows there is a red alert here, says weapon detected. She leaves the office. Then she returns to the office. Watch for the red alert. This is the red alert, says weapon detected. If I stop the video, just to show here, weapon detected 081 with 81% confidence that this is a weapon. Short weapons, handguns, pistols, long rifles, shotguns, AR-15 or whatever, swords and even knives will trigger an alert. And the thing that we have recently added is that the airport security, where we track people after facial recognition, image matching, we now track them based on gun carrying. So if you're carrying a weapon where you're not allowed at an airport or in the street or anywhere, the system will track you in the same way. It will fire an alert and it will display live, real-time, continuous tracking movement for your every step on a layout map of the location. So the authorities can know exactly where you are and have the alarm pinpointing your specific location, your trajectory, your speed, even your velocity, so they can go and intervene or do whatever they have to do. In addition, we have a system that is the access control by facial recognition. I want to also share that with you before we open the floor for questions. This is our office door, actually. And we have a little box here with a small camera. And the office is locked. It is locked by this heavy magnet system right here. And this solution we call open sesame. Think of it as a hotel room, and I'll explain what that means. The door is locked. When I take away and then move towards the door, as I approach my room door at the hotel, it opens. It opens for me. It opens only for me. It will open for no one else. The door opens. Look for my colleague Amir here. Again, the door is locked. He steps away. He just got his key from the hotel reception. He's checking in. This is the first time. And he goes, and the door opens for him. This eliminates the need for key cards, plastic key cards for hotel rooms. This is a great security tool. It will only open to you and those authorized, such as housekeeping, who are already having keys, and maybe your family, whoever you authorize to enter your room, and will open for nobody else. And will keep a recording of non-authorized people who are trying to open your door. And will keep a recording of every time you entered your room. So the system is intelligent, is made for security, it's also made for sustainability. Because look how much plastic you can give away, you can give up using by open sesame. So I share that with you so that you can generate ideas from this great innovation. Now I want to stop here, and I know I've shared a lot, so my apologies. I want to open the floor for your comments and questions.
Hi, Mohammed. Can you hear me?
Yes, sir. I can hear you now.
It's Russell here from Zest. A question around the intellectual property and the POPI Act and what have you regarding all this personal information that one would be capturing. Our particular application would be tracking of our employees on a construction site. What limitations, what do we need to be aware of in terms of the information that we gather in the system around their personal biometrics, in a sense, their face and that sort of thing?
These things are subject to the laws of the country and the relationship between the employer and the employee. You are already authorized to track your employees. That's in their contract. You are already taking their images during hiring process. And as long as you don't abuse the data and you use them for the specific purposes, I don't see an issue. You know, this solution is applied in factories and workshops throughout. So there is no, the problem happens when data is abused or misused. And for that, you always have the law of the land.
Okay, good. Thank you.
You're welcome.
Maybe just to add to that, obviously tracking a point cloud is anonymous. If somebody goes through a gate, you can add that specific ID to him. But it really depends why you're tracking your employees. Because I know in South Africa, you know, guys like com-iot will burn a factory down. I've been underground mines, you know, where people, for safety reasons, even just wanted to see what was going on. But there was some issues putting a face to a name. But yes, we would have to look into that specific application at the POPI Act. But like Mohammed said, I think if you employ a guy in a contract, there is ways to get around it. And obviously a point cloud is anonymous.
Yeah, I think a lot of these things obviously would just be advanced disclosure, just to make sure that's all upfront and it's a condition of the employment. I think that's most of the way there.
Yes.
Correct.
Also, if you do it for safety purposes and things like that as well, then there's a lot of leniency as far as I know concerning that. That could be explored.
All right. Any other questions?
There is one. Willem, go ahead.
Yes, Mohammed, I just would like to know, we're in a chemical factory, so is this equipment, except now for the cameras and so on, but that radar, is that intrinsic safe?
Is this requiring explosion proof?
Yeah, that it doesn't make sparks or ignite any fumes.
Right. So there are LiDAR sensors that are certified explosion proof, and we use them in oil companies and offshore sites, etc. So that's also possible. Probably not with Ouster though, but with other manufacturers.
Thank you.
Maybe worth mentioning also here, there is a very special enclosure being built for Ouster LiDARs through a company that we also represent called XLSense. It's a self-cleaning mechanism. They build cameras. Now, it sounds very simple. You guys will think just put an air purge on there or a water hose, but this thing actually works like a human eye, and it's a patented technology that actually cleans the sensor, and you can trigger that or you can do it event-based as well, which would obviously, you know, for let's say applications where I'm busy talking to some guys that's sitting next to an ocean or on vessels doing mining out at sea for the beers, the salt crust on these sensors can be taken care of. I don't know about the Apex rating of that enclosure. I will definitely find out from it, and that will be launched later on in this year. Gift?
Yeah, thank you very much, Andre. Thanks, Mohammed. I mean, I think you guys have got great technology. So I think, yeah, my question is around interface, or more on the software side. So does com-iot enable development companies to tap into any SDKs or any APIs, or the interface that we'll be getting from com-iot the one that we'd be using? And if that's the case, can we be able to make it fit the South African context? Because one thing that I've realized in the tech space is the South African landscape is quite different from other markets. So it needs to be put in the South African context, and that, of course, I think would need a bit more further manipulation of the algorithms, or even the interface of the data, the data itself.
Indeed, the I-Trac has been integrated with the milestones and genetic and advances and multiple other third-party systems. We have exposed AIs on REST basis and generating JSON files. We can integrate with your system, or we can give you our APIs and support you to integrate with our system with ease. This should be no problem.
Okay, thank you very much. Appreciate it.
Alex?
Hi there. Thank you. The one question I had was answered around the integration. So I see you, if you're with Genitech and that's cool. My question is, on the LiDAR, how many objects can you sort of track at a time?
Really, there is no limit. There is no set limit. The design team looks at the requirement. For example, if you're tracking people around Mecca during pilgrimage time, where you have tens of thousands or hundreds of thousands of people in motion in different locations, then the design will take that into consideration and will have as many LiDARs of the specific type as that case requires. Or if you have lighter crowd, then so that design will determine, but there is really no set limit. You can, manage crowd management. In fact, one of the things I wanted to mention is queue management. Like in airport security queues and immigration queues and the check-in queues, queue management system is part of our iCount features, where we not only manage the queue, we know the duration of time the queue is taken per person. We identify queue breaches when somebody comes from outside the queue and goes in the queue and all of that. So queue management system is an important feature of our people perception system.
So if I'm hearing correctly, basically, if the number of tracks increases, you just increase the amount of LiDARs you deploy.
That is
No.
that is maybe possible. It's one way to put it, but if the number of people is so very large, we will have sufficient point cloud to allow us to detect and track everyone, is really the point I'm trying to make.
Okay,
Mohammed, I think he's referring to within the footprint of a single LiDAR. So, I mean,
Yes.
correct me if I'm wrong, if the LiDAR, if it's visible to the LiDAR, that single LiDAR will track everybody in its
That single
footprint.
LiDAR will track anybody, everybody, all of them, with
Yes.
one sensor.
So what Mohammed is referring to, if he moves from one footprint to another, these things are set up in a network, so it will keep on tracking him continuously around corners, through buildings.
Okay.
Correct.
Okay.
Correct.
Okay. With that unique ID of the track.
Correct. With the
Okay,
unique
that's
ID.
pretty cool. Very, very cool. And then, so basically the application that we're looking at is on a mine, where if we have a, like a pit invasion, where on a normal condition, the open pit is working as normal and whatever. And then say at nighttime on the weekend, there's an invasion, and it could be anything from, it could be thousands of people. And that's a sort of behavioral analytics we want to look for, where if there's an anomaly in amount of people and in an area, then we need to raise an alarm, and we need to kind of estimate the number of tracks or people that are present in that particular invasion. Is that sort of thing possible?
All possible. That's exactly what the system does.
And it won't be an estimate. You'll know exactly how many people there is.
Very cool. And would one be able to run like a report or a statistic based on those number of tracks in that in a given time?
You bet. Absolutely. As you have seen, the dashboard itself is very intelligent. It allows for analytics, filtration, comparative analysis, and much more, in addition to real-time display of the data caption. So it's a data collection machine.
Okay, very cool. And then my other question is, what sort of distance are we looking at in terms of coverage by LiDAR?
So different LiDAR have different ranges. We are working with LiDAR sensors that reach 150 meter in radius, or 50 meter or 60 meter. So it really depends. For example, I think I have, let me see.
Alex, while Mohammed is looking, also just to accentuate the point. So this thing is invisible at night. It doesn't, it's no visible light. So you don't know it's there, and it does all that. You don't have to install any lights as well.
Okay, cool.
Yeah, so this is an airport, and this is the perimeter of the airport. And if you look at this here, these are LiDAR sensors. We place these LiDAR sensors at specific spacing that ensures continuous coverage. I have shown the video where you have multiple LiDARs, multiple PTZs, and multiple zones. This is exactly the same thing. And you would just make a design to accommodate the requirement. In this case, this airport wants all the perimeter covered. And because here in this area where my mouse is a lot of ins and outs and angles and corners, more LiDARs are required to ensure full coverage. So here the distance is less meaningful, but when you have open areas like this, you stretch out the distance to the max to minimize the number of sensors required and reduce the cost.
Okay. And what sort of power consumption do these devices need?
So they take main power, so regular power, 220 volts. I think it's about 20 watts.
20 watts. Okay, cool. 20 watts.
So we looked at applications on a base here to obviously cover for load shedding.
Yes, you know how it is.
That's exactly what. So yes, to make like standalone units. So that is something that we looked at here, and it's not big. It's small. We can put everything on a pole.
Okay. And would
it's not big, it's small. Sorry, I think I said that it's a small requirement.
No, I get you. I got you. Yeah. And would you guys ever be able to extend on the range? Because in our applications, obviously the pits are quite large, and we have like a container with a thermal camera up on top and that sort of thing, surveying an area of possibly, I don't know, call it 4 square kilometers or something like that. And we make use of radars to do our detection, and we can obviously go like, we've got a 3-kilometer radar and that sort of thing. So the distance of 150 meters is quite low for us. Would you ever get something that's going to be in the distance of, 500 meters, kilometer, and that sort of thing?
So are you currently getting false alarms?
Look, there's all kinds of detection, but in this particular application that we're looking for, radars are not cutting it for us because of the inaccuracy of the tracks and being unable to really uniquely identify them. And when you have a crowd, you can't really tell what the number of, you can see them on